Welcome to AngularJS scopes tutorial. In this tutorial, we'll cover through what are scopes and its characteristics, and we'll also go through the scope inheritance. So what are scopes? Scope is an object that refers to the application model, and scopes actually provide context against which Angular expressions are evaluated. For example, if you consider this expression name within the double curly braces, this expression standalone, it doesn't have any meaning unless it is actually evaluated against some specific scope, which defines that particular name property. So, scope acts as the glue between application controller and the view. Particularly during the template linking phase, when Angular directives set up watch expressions on the scope, and these watchers allow the directives to be notified of property changes, which allows the directive to render the updated value to the DOM. So both controllers and directives have references to the scope, but not to each other. This kind of arrangement isolates the controller from the directive as well as from the DOM too. This is particularly a very important point since this makes the controllers view agnostic, which also helps in testing aspect of the applications. Scopes are arranged in hierarchical structure, which actually resembles the DOM structure of the application. Scopes can also watch expressions and propagate events. Coming to the characteristics, scopes provide APIs to observe model mutations. So the $watch, which is shown here, this corresponds to the API, which actually registers a listener callback, which needs to be executed whenever this watch expression changes. So the watch expression is called on every call to digest cycle, and this should return the value which would be watched further. And the listener, which is specified in the second argument here, the listener is called only when the value from the current watch expression and the previous call to watch expression are not equal. And the third argument here, the object equality, this is just an optional parameter, and by default, this value would be false. So comparison would actually be based on reference equality, and if this parameter is set true, comparison would be based on angular.equals instead. So the watch listener may change the model and which might further trigger other listeners to fire. And this is generally achieved by rerunning all the watchers until no changes are further detected. And in order to avoid the loop to be ending up in some infinite deadlock, this rerun iteration limit is limited to 10. And scopes also provide APIs to propagate any model changes through the system into the view from outside of the Angular framework. So the $apply is used for that particular purpose, and this is used to execute an expression in Angular from outside of the Angular framework. So this particular method transitions through following changes. So in the first stage, the expression would be executed using the $eval method. And in the second stage, if any exceptions occur during that execution of that expression, those are forwarded to the $exception handlers core service. And in the last stage, the watch listeners are fired immediately after the expression was executed using the digest cycle. So coming to the inheritance, in any Angular application has exactly one root scope, but it might have several child scopes. And the application can actually have multiple scopes because some directives can also create new child scopes. And when these new scopes are created, they are further added as children of the parent scope. So this actually makes it create like a tree structure which parallels the DOM where they are attached. For example, when Angular tries to evaluate some expression, say the name expression, like what we were looking before, the name within the curly braces, say consider this as an example. So it searches for this expression within the current scope which is associated with the given element, and uh, for the name property. And if no such property is actually found within the current scope, it starts searching in the parent scope, and it iteratively goes until it reaches the root scope. So this kind of behavior is actually known as prototypical inheritance in JavaScript. And similarly, child scopes also prototypically inherit from their parents. But sometimes when you actually require to build reusable components so as to prevent a component from changing your model state, except for the models that you explicitly pass in, you might actually require isolated scopes which do not inherit prototypically from their parents. So in such cases, isolated scopes can be useful. So with this, we actually covered the scopes topic in this tutorial. Thanks for watching the video.